raining during this recording? Okay. Oh well. If it comes in, you can shut the window, but I think it's okay for now. But if it does start to come in, just shut it, okay? Alright. Let me start my video over. Never mind, we're going to leave it. Okay. So 1.9 is special functions. So our essential question is, how are piecewise function graphed and evaluated? And the lesson target is graphing and interpreting piecewise functions. So what is a piecewise function? A piecewise function is a function made up of pieces of equations with restrictions. The rules are each piece only stays within its restricted area. Okay, so it's like restricted to a certain domain. Okay, a certain set of x values. And when we talk about restriction, when we have an equal sign underneath, we use a closed circle. And when we have no equal sign underneath, we talk about an open circle. Okay? So let's go ahead and try one of these. So right here it says y equals x plus 2. And that would be restricted between x is less than 1. Yeah, you can shut it. Yeah, you just turn it. Hang on, let me pause my recording. You know? Alright, anyways, what was I saying? So, we're looking at the function y equals x plus 2, where it's less than 1. Okay? So what you want to do is, the easiest way to go about doing this is to make a table, in my opinion. So we make a table, and we want to come up with a few values that are going to be useful to us. So I know that all my x values are going to be less than 1, so I'm going to come up with a few that are less than 1. So I usually say like -1, 0, and 1. Now, you always want to include the end and the beginning of your restriction. If you have it beginning or end, you always want to include that point when you're making a table, okay? Whether or not it's equal to or less than or equal to, you always want to include it in your table. So what we're going to do now is we're going to plug in each of these x values into the equation. So I get y equals -1 plus 2, which is 1. Now I'm going to do it with y equals 0 plus 2, which is 2. And then y equals 1 plus 2, which is 3. So now I'm going to plot these points. So -1, 1, 0, 2, and 1, 3. But 1, 3 is going to be an open circle because I only have an equal to here. Okay, it's going to be an open circle. Sorry, it's tiny. Now I'm going to connect it like this because x is less than 1. Okay? So now that we did this part, we're now going to do this part down here. Okay? This part down here. So that's going to be y equals 1 or x minus 1. And that's going to be from x is greater than or equal to 1. So once again, I'm going to make a table here. And I only want to include values in my table that are actually going to occur on my equation here. So we're talking about values that are greater than 1. So I want values that are 1 and bigger. So 1, 2, and 3 are good choices. And now I'm going to plug these values into my equation. So 1 minus 1 is? Good. 2 minus 1? And 3 minus 1? 2. So now I'm going to plot these. So I have 1, 0. And is 1, 0 going to be closed or open? Closed, because of the equal sign. Good job. And then we have 2, 1. And then we have 3, 2. And now we need to determine which way the arrowhead is going to go. Now in this case, x is going to be greater than 1, which means my arrow is going to the bigger numbers on the x, this way. So this is what a piecewise function looks like, okay? Yes.
Why was the first one you did that warning was open and now it's closed?
Sure. So the reason that the 1 was open is because see the restriction here, how it's x is less than 1? So 1 is technically not included in that value because it's always got to be less than 1. So every value less than 1 is included, but 1 itself is not actually included because of the lack of the equal sign here. Does that answer your question? Okay. Do we have any other questions before we move on? What?
Can you zoom out a little bit?
Yeah, sorry. I was trying to make sure everybody could see it, and then I was like, not zoom in more. There we go. So take a second if you need to get this part down. So now we're gonna graph another piecewise function. So this one has 3 pieces this time instead of 2. So the first thing you're gonna do is look at the top one, and you're gonna create a table based on its restrictions. Okay? So I know I'm dealing with y equals 2x plus 1, where x is less than 1. So the first thing I want to do is I want to create a table that's going to satisfy my restrictions. So if x is less than 1, I want to pick a few values less than 1. But remember, you always want to go up to whatever this number is. You want to include that in your table. So I usually do 3 values. You could do 4 if you wanted to, if you wanted to give a little more information. Okay? So now I'm going to plug each of these values into my equation. So you got 2 times negative 1 plus 1. So 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Now for 0, 2 times 0 is 0. 0 plus 1 is 1. And then lastly, we have 2 times 1 plus 1, which is 3. So now that I have these values, I'm going to plot these on the graph. So it's going to be negative 1, negative 1. It's going to be 0, 1. And lastly, remember, 1 actually isn't included on my graph, is it? So it's going to be 1, 3, but it's going to be an open circle. So it's only open where the restriction occurs if the restriction doesn't have an equal sign. Does that make sense? I'm not sure how best to word that. Okay. And we know that x is less than 1, which means that my arrowhead is going to go this way. So now, for the next one, we're going to look at the next piece of the piecewise function, which is going to be y equals negative x plus 2, and it's restricted from 1 to 2. So I'm going to make a table. Now in this case, we have 2 numbers in the restriction, so you need to make sure both those numbers are included. In this case, 1 to 2, we're only going to have to include 1 and 2 because there's no values between that to include. So I'm going to plug each of these values into my equation and see what I get. So this is going to be y equals negative 1 plus 2, which is 1, and y equals negative 2 plus 2, which is 0. So that's what I'm going to plot on my graph. So 1, 1. Now 1, 1, is that open or closed? Anyone know?
Closed.
Good. Now the 1 is closed because we look at the x value. That's part of the inequality. It has an equal to sign, so this is closed. The 1 is closed. Now for the 2, is the 2 open or closed? Open. Good, this is open. Now we're going to connect that. Now this one actually has no arrowheads. Does everybody understand why this one has no arrowheads? Okay, so whenever you have a compound inequality like that, there is no going to infinity. Therefore, there is no portion that's going off to infinity there. It's bound. Okay, it's a bound inequality. So, lastly, I'm going to have to erase this first one to make room. Lastly, we're going to talk about the 2. Now, this is the one that seems to confuse students the most, so I want to make sure I'm really clear about this. So we have y equals 2, and that's bound from when x is greater than or equal to 2. So we're going to make a table, and we're going to pick a few x values, okay? So we're always going to use the value that's on our inequality, which is 2, and I'm going to pick 3 as well, and we'll just pick 4 too. We'll do 3. And this one is weird because what's wrong with the equation here? Can I plug anything into it? No, there's no x to plug in. So y equals 2, what that's saying is y equals 2 is the whole thing. Everywhere it's always y equals 2. All the y values on this function are 2. Anybody know what kind of line it is, y equals 2? It has a special characteristic. Yes.
It's straight, isn't it?
Yes, it's straight. It's actually horizontal. Yes, it's horizontal. When you have x equals a number, it's a vertical line. When you have y equals a number, it's a horizontal line. So, anytime you're dealing with just a number like this is a horizontal line. Okay, and you know where that horizontal line is. It's wherever that y value is that it's going to exist, okay? So I'm going to plot it. 2, 2, which is included, right? Everybody understand why that's a closed circle right there? 3, 2, and 4, 2. And it's going to infinity this way. Everybody understand how I knew it's going to have an arrowhead on it? Feel free to ask if you're confused of any of this stuff. It can be a lot to take in at once. This is what a piecewise function looks like. It's like you cut a bunch of pieces of functions apart. Now, you'll sometimes see people write their piecewise functions with these little dashed lines in between. If this helps you visualize it, feel free to do that. This just helps you see where the different pieces kind of meet up. So before we talk about domain and range, does anybody have any questions for me so far? It's okay to stop me if you need to. All right, so let's talk about the domain. Domain are all the possible x values. So what do you notice coming from the left here? What's happening right here? It's going down, and it's going down forever, so eventually it's going to keep going this way. So are we going to eventually take on every x value? Yeah, we will. So it's from negative infinity to positive infinity, because it's basically going like from here. This goes on forever this way. So eventually it's going to go out this way. Okay, so it's going to like angle. Now over here it's going straight across this way. This one's going faster, but it is going to positive infinity. Now, for the range are all the possible y values. So looking at my range from the left side, I'm definitely going to be taking on all of the y values this way, right? Because I'm going downward. So from negative infinity. But what's my highest range value here? 3. But is 3 included or not? No, so it's a parenthesis, because the 3 is open circle. So it doesn't actually hit 3. Okay, it hits just before 3. The reason we use 3 is because we're not going to write 2.999999 repeating. Okay, it doesn't actually hit 3, but it's just below the 3. So we use the open bracket. Anybody have any questions on this one? All right. Now we're going to talk about determining what's true and false about a piecewise function. So put arrowheads on this because there aren't any, but it indicates there are. So yes, they're going on forever. So now we want to determine if this graph is a function. Now, the easiest way to do this is to see if it passes the vertical line test, right? Now this is a little tricky. So if I draw a vertical line here, it looks like it hits 3 points. But does it actually? No, it only hits how many? 1. You guys are smart. It actually is a function because it passes vertical line test. So when you go through an open circle, that doesn't count as hitting your graph. Okay, because it's like you're going through this like that. So it's not like actually hitting it. So what about the range? So the range is up and down. Okay, so let me erase this to not throw you off, because it throws me off when I look at it like that. So what's the lowest that it goes on the y values here? Looks like around the -1, right? And what's the highest that it goes?
6.
It actually, yeah, it goes to infinity, right? But does it go to infinity negative, the negative direction? No, so this is false. The range goes into positive infinity, but doesn't go into negative infinity. F of x is undefined at f of 9. So we talked about this notation a few days ago, but in case you forget, all this means is where x equals 9. Okay, that's what they're saying. So what we do is we look at where x is 9, which is right here, because the graph's going by 3s, which is odd, but it is going by 3s. So when x is 3, is there a point on the graph? I mean, when x is 9, is there a point on the graph? Yeah, there is. So that's false. There's a point right here that has x as 9 for the coordinate. X-intercept is 8. Well, this is 6 and this is 9. So I would say this is around 8. What do you guys think? So I would say this one's true. Everybody see why D is true?
Yes.
Okay. Yeah, it's a weird scale. The graph's going by 3s. But yeah, it is actually around the... and then what about the y-intercept? What do you guys think? Is that 4?
Yeah.
True. That's true. Any questions on this part? All right. Now we're going to talk about step functions. So step functions are a type of piecewise function that contain all constant pieces. We call this a staircase function because it looks like a staircase. Okay? So when you see the word constant pieces, anybody know what that means in terms of a graph? It means all the pieces are all horizontal lines. So horizontal lines are known as constant functions. So if you do want to note that, it's not a bad idea. All right, let's look at some step functions. So this is a step function here. Now whenever you're dealing with a step function, all of the numbers over here are just going to be numbers. They're not going to be with variables in them, and that's because that's how you get horizontal lines in math, just numbers. So you don't actually have to go through and do all the work because it's always going to be straight lines. You just have to figure out where those lines end, begin, and where they lie. So the easiest way to do this is, let's look at where my line's going to be. So this is a f of x is equal to 1 here. So I know that it's going to be right here, my horizontal line. Now the next thing I have to determine is where it's going to end and where it's going to begin. So, x is less than 0. So, and is it open or closed? Open. So you draw an open circle where x is 0, and I know that it's going to the left. So this determines where you are on the y-axis. If that helps. So we look at where this is on the y, and this tells us where to start on the x. Any questions about that part? All right, let's try part 2. So now we're going to be at 2, the y location, and we're going from 0 to 2. So at the 0 for the x, are we going to be open or closed? Closed. And then we're going all the way to the 2, and above the 2, are we going to be open or closed? Open. So anytime that you have a bound inequality, a compound inequality, you're not going to have an arrowhead because it's not going into infinity. And lastly, we're looking at f of x at -1. So this is my y location. And now I'm looking at the x at 3. Is it open or closed? Closed. And I'm going to positive infinity because x is greater than 3. So this is what a step function looks like. So I know a lot of you probably think like step function, they can look like this, but they can also be like weird shaped steps. It just means they're all a bunch of horizontal line pieces. Okay, that's all it means. So it can be like weird steps or normal steps. Any questions so far? Have you guys seen these before?
No,
No?
not really.
Okay.
Some of the algebra ones, like,
Yeah, I think some.
we briefed it.
When I taught Algebra 1 a few years ago, I thought we talked about it like a little bit.
Like at the end of the year, we briefed it.
Yeah. Alright, so now we're going to do a word problem. This one's a little weird. We're going to talk about it though. So it says here, Orlando Airport short-term parking sign is displayed. It says if you park for 2 hours or part thereof, weird way to say it, but basically 2 hours or less, it's $1. If after that, each additional 2 hours is $3 more. And then, if you hit the maximum, which is 24 hours, you're paying $10 max. So let's look at what the function is going to look like. It's going to be a step function, okay? So, for the first, it's going to be $1. Okay, we know we're going to pay $1 because cost is a function of y. Okay, it's the y. Cost is the y. Time is the x. So it's going to be $1 if you park from anywhere from no hours at all up to 2 hours. Now I want to talk about how I knew where the equal sign and where the equal sign is and isn't. So think about it this way. If you park for 0 hours, are you going to have to pay for parking? No. So that's why the 0 here is not included. Because I'm not going to pay if I haven't even parked. Now, if you park for exactly 2 hours, you're not going to pay into the next pay rate. You're going to still pay $1, right? So that's why 2 is included. Does that make sense? Okay, so it's always like one picks up where the other one leaves off in this. So the next one. So each additional 2 hours. So if I plot this on the line, that's going to be from here to here. So I'm starting at 0, time of 0. You're not paying anything, but then the second you pay, if you only park for like 30 seconds, you're still going to pay $1. You know what I'm saying? Even if you park for like 30 seconds. So that's why it starts here, and then up to 2 hours, it will cost you $1. So after that, you're going to pay an additional $3, right? So if you park for say 3 hours, how much are you going to pay? Well, you would pay $3 additional. So how much would you pay total? $4. So you'd pay $4 if you parked between 2 hours and 4 hours. because that's 2 additional hours. So that will look like this, from here to here. Now, say you go past the 4 hours, and you're gonna have to pay for another 2 hours, so up to 6 hours, right? How much are you gonna pay then? It's a little confusing. 7, right? If you go into the next one, you're gonna have to pay an additional $3, so that's gonna put you at $7. And that's from anywhere from 4 hours to 6 hours. So if you leave by 6 hours, you don't have to pay more. So that's going to be from wait a minute, I messed this up. This should be at 4. Why did I do it at 5? Sorry about that. So at 7, it's going to be from here to here. Now, if you go past 6 hours, you got to pay for another 2 hours of parking. How much is that going to cost you? Not 9, but you're going to add $3. 10. Now, what do you notice also about $10? Can you pay more than that? That's the maximum rate, up to 24 hours, right? So anywhere from 6 hours to 24 hours is going to cost you the $10. So at 10, so from 6 hours all the way to, I should have drew that line better. I'll fix it. For 24 hours, that's going to cost you $10. So this one's like one of those ones you kind of have to think about for a second. But do you guys kind of get it? Okay, so let's talk about the domain. So the domain deals with the time. So what's the minimum amount of time you can park somewhere? Anything greater than? Yeah, so anything from 0 up to 24 hours. Now, does everyone understand why the 0 is a parenthesis? Because 0 is not included, because you're not going to pay to park 0 hours. But why is the 24 included? Because you can park for the 24 full hours, right? So that is included. Now we're going to talk about the range. So this is the minimum to maximum cost. So what's the cheapest the parking's ever going to be for you? $1, and that's included because the $1 is definitely a price. And what's the most the parking's ever going to cost you? $10. So this one's a little bit of a challenge problem. You don't have anything like this on your homework, so don't worry too much. Alright, you guys have about 40 minutes to get some homework done. A little less than 40 minutes. I will do attendance and a few other things, and then I'll walk around to give you some help if you need it. Let me know if you'd like me to do another example on the board from the homework. Okay?
Can I use the restroom?
Sure.
And do you post your